Hey guys, it's Miss Hampton. We're gonna talk about the Sieve of Eratosthenes today, as we're learning about some prime and composite numbers here. So, who is Eratosthenes? You might ask. What word is that? So he was a Greek mathematician a long time ago, like back in 200 BC, that did lots of cool things like making a really accurate measurement of the size of the Earth. But what we're interested in is that he came up with this method for finding all of the prime numbers from 1 to 100. So, what's a prime number again? Just to refresh your memory, it's a number that has exactly two factors, just itself and 1. And remember, factors are the numbers that can be multiplied to equal your number. So, for example, 6 is not a prime number. Facts that equal 6 are 1 times 6 and 2 times 3. So 1, 6, 2, and 3 are factors of 6. Since there's more than two factors, 6 is not prime. It's composite. 5 is an example of a prime number. There's only one fact that equals 5, 1 times 5. So its factors are 1 and 5. Since 5 only has two factors, that makes it prime. Okay. So how does the sieve work to find all the prime numbers from 1 to 100? What you're going to need is your hundreds chart. So grab that and then grab like 5 or 6 colors, as many different like colored pencils or things as you can. You can do this with just a pencil, but it ends up looking cooler with colors. So take a second, pause if you need to, and grab what you need. Okay, next thing, we are going to cross off all of the composite numbers, and then we're going to end up at the end with all of your prime numbers circled. We'll start with the number 1, and we're going to work our way up. So let's look at the number 1. It is remembering that a prime number is a number that has just exactly two factors. So there's only one fact that equals 1. It's 1 times 1. So that means 1 only has one factor. So it is not prime. It's actually not composite either, but it's not prime, and that's what we care about today. So you're going to pick a color. I chose red, and you're going to cross off the number 1 because it is not prime. All right. Let's look at the next number, number 2. Thinking about the factors of 2. 2 times 1 is the only fact that equals 2, so 2 and 1 are the factors. That means, since it only has two factors, that 2 is prime, and the only even prime number, by the way. Okay, so you're going to pick a new color. I chose orange, and you're going to circle the number 2. Now here's where we get fancy. All the multiples of 2 have 2 as a factor. So think about some of the multiples of 2, like 4 or 6. All of those numbers are going to have 2 as a factor. So that means none of them are going to be composite. They're all going to be composite. None of them are going to be prime. They're all composite. So since all multiples of 2 are composite, let's cross them off. So I took the same color that I circled 2 with, and I crossed off all of my multiples of 2. So you might want to pause the video, take a minute to do that. All right. When you have crossed off all the multiples of 2, let's look at 3. Factors of 3, just 3 and 1. That's it. So that makes 3 another prime number. I'm going to pick a new color. I chose green and circle 3 since it's prime. Now we get fancy again. Using the same logic we used with 2, all the multiples of 3 are going to have 3 as a factor, like 6 and 9 and 12. All of those numbers have 3 as a factor. So that means they're all going to be composite. They can't be prime if they have 3 as a factor. So I'm going to take that same color green and cross off all of my multiples of 3. Notice while you're doing that some of them are already crossed off. Think about, what does that mean? You might even want to write down a reflection about that, because that's going to be a reflection question later. What does it mean if some of them are already crossed off? Okay, once you are finished crossing off the multiples of 3, let's look at 4. It's already crossed off. Oh, right, because it's composite. It's a multiple of 2. All right, so let's skip ahead then and look at the number 5. Factors of 5. 5 and 1 only, so that makes 5 prime. Yep. So let's pick a new color. I chose blue and circle it. It's a prime number. So far we have 3 prime numbers, 2, 3, and 5. All right, we're going to use our fancy logic again, and all the multiples of 5 are going to have 5 as a factor, like 10, 15, 20. All those numbers have 5 as a factor, so they have to be composite. I'm going to use my same color blue and cross them all off. Thinking again, I'm running into some that haven't been crossed off at all, some that have been crossed off once, and some that have been crossed off three times now. So, what does it mean if a number has been crossed off twice or three times? All right, moving on to the next number, 6. It's already crossed off since it's composite. Actually, it's crossed off twice because it was a multiple of 2 and a multiple of 3. So let's skip ahead, look at the next number, 7. Think about the factors of 7. Just 1 times 7 equals 7, so that's 2 factors. That makes 7 prime. Yay! Okay, since 7 is prime, we pick a new color. I chose a kind of magenta-ish, pinkish, purplish color. We circle it, and then we get fancy again. We know that all of the multiples of 7 are going to have 7 as a factor, so that means they're all going to be composite. We can cross them off. As you're crossing them off, think about this question. What do you notice about the number of new things we get to cross off? Meaning like the number of numbers you crossed off that had not been crossed off before. Like this time I noticed the only ones that were brand new were like 77 and 91. Like that's not very many. Okay, so now we kind of need to think about what Eratosthenes proved. He said that you only have to follow this process until you get to 10. So if you look ahead to 10, I know we just finished 7, but look ahead to 10, we've already crossed off 8, 9, and 10. So we know those are composite numbers. So we're finished at this point. Yeah, it's pretty awesome. So let's see what this means. The only numbers that are left now that you have not crossed off are prime numbers. These are all the prime numbers from 1 to 100. So since they're prime, we want to circle them just like we circled 2, 3, 5, and 7. So I grab a different color. I chose black. You can choose whatever you want and circle all your remaining numbers. You might want to double check with mine to make sure that you got the right ones because we're going to keep this as a reference. All right. A couple more things to think about here. Did you notice any patterns in the numbers that are prime? Or did you not notice any patterns? That's kind of notable too if you didn't notice any patterns. Did you notice any patterns in numbers that are composite? Even just in your multiples of just 2s or your multiples of 3 when you were crossing those off, did you see any patterns? All right, you are finished and have completed your Sieve of Eratosthenes, and you now have a reference that you can keep in your notebook of all the prime numbers. That is going to be super handy. So please make sure that your Sieve makes it into your notebook. You are going to want it, I guarantee. Thanks for watching, guys.